Hello, everybody, and welcome to our reschedule of the 2 o'clock talk, Sounds of Open Source by Dmitry Dolgov. It's rescheduled because we had some technical issues at 2 p.m. Fortunately, we were able to get a recording of Dmitry's talk to give to you. Unfortunately, we weren't able to get Dmitry back for the Q&A, so we will go ahead and start with Dmitry's talk. I hope you all enjoy it.
Hi everyone, thanks for watching this presentation. My name is Dmitry and today we're going to talk about sound processing tooling. So here is a plan. First of all, I'm going to explain why am I going to talk about this topic at all, because usually I'm giving talks about databases. Afterwards, we're going to talk about one particular tool called Sound Exchange, about its history and features, and afterwards we will talk about how to create a small but interesting audio project step by step using these features. So we're going to talk about recording audio, cleaning it up, creating a structure from it, applying some different effects, and so on and so forth. But first of all, a little bit of a background. Some time ago, I had an interesting idea about creating an audio project. The idea was rather simple. Essentially, I wanted to compile a single relatively large audio track from a bunch of small audio inputs. I wanted to arrange them somehow, create an internal structure, apply different effects, and so on and so forth. But the final result, I wanted to make it as smooth as possible. So I wanted to avoid any kind of distortion or any kind of distraction from the listening experience. Usually when you have to work with sound, you just take something like Audacity or something and you just go with it. But here I actually had a special requirements. I wanted to find a tool. That will have a command line interface. And the reason is that pretty much simple. First of all, I knew that I'm going to work with a lot of small files, which means that there will be a lot of repetitive actions. And at the same time, I knew this, as a newbie having no prior experience in this area, I knew that I will never ever make the whole thing right from the first attempt, which means that most likely I will have to recompile this project over and over again, and it better to be scripted from the start on. So having these requirements, I started to do some research, and it turns out that there are not that many open source tools that actually satisfy those requirements, unfortunately. One of those tools that I have found called Sound Exchange. This tool actually positions itself as a sort of like a sweet arming knife for sound processing. But originally I was pretty skeptical about this project because, well, it's unfortunately a pretty common tragedy story, common for the open source world. This project didn't look well maintained, unfortunately. The last release was in 2015. The Git history had a lot of significant gaps in it. Nowadays there is a small community working on it, there is some activity, but still I was pretty skeptical. At the end of the day, I decided to give it a shot, and it was an absolutely amazing experience. The tool is just great, it does exactly what I wanted to do, and after all, I find it actually pretty unfair to this project that, well, essentially, via this presentation, I want to even give a little bit of recognition for this project. So, and now let's talk a bit about which steps you actually would need to apply this tool, to use this tool to create something interesting. This is actually one of the problems of this project, the documentation. So aside of relatively dry manual pages and some blog posts, how to do this and this, it's pretty hard to find something more tutorial-like, when you will find the steps that you have to do that will just give you a higher perspective on the project. So that's what we're going to talk about in the following slides, and the obvious first step always is actually to record some audio. Fortunately, Sound Exchange is not just a single tool, it's actually a set of tools, and one of those tools allows us to record some audio with different parameters and everything. Well, honestly saying, I was actually recording audio with something different. I was recording it with FFmpeg because of a little bit more flexibility, but, well, that was the whole point and idea behind using something with a command line interface to be able to mix and match tools together, and in this case it played actually really nice. So, recording is just a part of the story. We also have to decide which audio format are we going to work with. And that's a significant choice because, well, there are of course much more formats than I have presented on this slide, but I've put those three as a probably most representative because they're bringing a lot of things on the table, and this a lot is mostly evolving about compression. So, for example, wave format does not compress your audio at all, which means that it's probably good because then you're not going to lose quality, but at the same time, the final result is going to be pretty big in comparison, especially with, for example, with MP3. MP3, in contrary, actually does an interesting compression. There are interesting algorithms to compress stuff, but unfortunately they are lossy compression, which means that eventually you're going to lose a little bit of your quality. Sometimes it could be not noticeable, sometimes it could be, but still it's a thing. Although you can still win a lot of disk space, especially in comparison with, for example, Wave. So, as an example for the project, the final result I was having with Wave format was about 16 gigabytes. When I have compressed it with MP3, it was reduced to about 800 megabytes, so like an order of magnitude, which is significant. And FLAC format is actually, well, it tries to combine both, like best from both worlds. It actually employs some compression, but it's a lossless compression, which means that you're not going to lose any quality, but probably, yeah, the compression level is going to be a little bit worse than with MP3. Okay, so at this point we have to decide this part and imagine that we already have some recordings ready for us. At this point, we are not even remotely ready to actually start to composing something because, first of all, we have to process these input files. We have to clean them up. And the most straightforward first step is actually to get rid of the background noise. The thing is that no matter how much efforts do you put into the recording, there will be still some amount of background noise. Fortunately, Sound Exchange allows us to get rid of it, and that's how it works. Essentially, you have to create a recording that contains only the background noise, nothing else. Afterwards, with the Sound Exchange, you can create a noise profile for this background noise, for this file, and then for every new file, you can tell, please exclude this particular background noise that's described by this noise profile. Which is pretty nice, and to make it even more interesting, we can visualize this procedure. So we can create a couple of spectrograms. Here on the slide you can see two of those spectrograms. They have on the x-axis they have a time, on the y-axis they have a frequency, and two channels per each. The only difference is that on the left spectrogram you can see an audio file with the background noise, and you can pretty much see it because, well, yeah, there is indeed, like, it's polluted by the background noise. Almost every point has some amount of frequency in it. And as soon as we remove this background noise, we can get a spectrogram like on the right side, where you can see that the signal is pretty much more cleaner, and it means that it will be much nicer to listen to. And just a little bit interesting information, of course this functionality is implemented using fast Fourier transformation, which is a powerful approach. Essentially it works in a way that it will split your signal into several frequencies that you can just filter out if you need to, and it's pretty much common approach, people are using it everywhere. So, but at this point, again, we are not even remotely finished with cleaning up. The next point you'll find out, the next issue you'll face is a silence frame, short pauses frames at the beginning and the end of your audio files, which is pretty much expected because obviously there is a short time frame after you have clicked the record button and before you have started doing something. And the very same is true for the end of the file. So the cleaning up of those silences could be pretty much cumbersome if you're doing this manually, but fortunately Sound Exchange allows us to do this automatically using voice activity detector, which is essentially a detector that will it will essentially trim out those silences at the beginning and at the end of the file based on the audio volume level, which is pretty convenient. So this part is done, and then we have to deal with the volume level actually. For me as a newbie in this area, I found out that the volume was probably the hardest part of this whole project, harder at least than I was imagining it. The thing is that it's again, no matter how much efforts do you put into the recording, it most likely will be that different files will have a different volume level in it, unfortunately. And if you're just going to merge them like that, it means that in the final result throughout your project, the volume level will be just jumping back and forth, creating pretty unpleasant experience, which is not nice. So fortunately with the sound exchange we can specify, we can like sort of try to manually adjust it, we can specify for every input file which volume level we want to have. But for that, of course, we need to have some reference points. And those reference points, again, we can get from the sound exchange. Essentially, we can try to ask it to get some statistics about our audio files. Here on the slides, you can see one of such examples, one of such statistics, where you can, for example, take a mean signal norm or another interesting and important parameter called volume adjustment, which is essentially a coefficient that you can use by which you can actually increase the volume level without getting into the clipping. About this a little bit later more. So yeah, in this way you can make it make a rough adjustments. But unfortunately, rough adjustments still could be heard at the end as some sort of a distortion or unpleasant experience. It still would be that your final result will have some parts that are much louder than other, or for example, much quieter than they're supposed to be. And fortunately, we can actually make it smoother using an automatic gain control functionality that also Sound Exchange provides us. So, on this slide you can find a pretty elaborate command to actually deploy this gain control, but it's easier to think about this in a visual representation. So here is a graph, which is a transfer function graph. Here on the x-axis we have an input level, and on the y-axis we have an output level. So essentially what are we doing using this automatic gain control? We are transforming input audio, input level, into the output with following some certain function. Here, for example, you can see that for all the sounds before 40 decibels we are not doing anything. We transform them one to one without any changes. And afterwards, approximately at 35, I believe, we are getting flat-lined. What does it mean? It means that all sounds that are higher than that are going to be pulled a little bit down, and all the sounds lower than that are going to be boosted a little bit to make the overall hearing experience, listening experience much more nicer. And overall, it makes indeed quite a lot of difference at the end. So now we can say that we are more or less finished with the cleaning up, with the preparation phase. Now we can actually start to create a structure from these input files, structure that we want to see in the final result. Here we can, for example, concatenate different audio files and merge them together, apply different interesting effects and so on and so forth. But there are still a couple of issues you need to know about, otherwise you probably will get some pretty unexpected results. For example, one of those is again at the volume level. The thing is that Sound Exchange is actually a pretty smart tool, so that every time when you're trying to merge a couple of audio files, it will try to adjust the volume level of the resulting file so that it will try to avoid clipping. The thing is that it does it like implicitly. Well, there are probably some warnings in the command line, but like otherwise it's pretty implicit for you, which means that at the end you can get a final merged result that will be much quieter than you wanted it to be, which is probably, well, surprising sometimes. So you better to specify explicitly which volume level you want to have from the final result. Yep, and at this point we already mentioned clipping many times, so let's talk about this. What is it all about? Well, essentially clipping is it's a sound distortion that you want to avoid most of the time. Clipping is the situation when your volume level is higher than your format representation actually allows it to be. So to make it to understand it visually, you can take a look at this slide where we have a pulse code modulation, where we have a wave, just a wave that we're trying to put into some borders, into some limits. But unfortunately, this wave is too strong, too big one, and as soon as it hit this border, this red line, it has to get flatlined. Otherwise, it will not fit into those borders, unfortunately. This at the end for audio means, of course, an audio distortion and normally, well, produce a not really pleasing listening effect. Just a side information, usually when you're reading about this, you find the term unwanted clipping. And all the time I was thinking, like, why unwanted? Like, is there a such thing as a wanted clipping at all? Turns out that, yeah, indeed, it turns out that many metal bands who are using guitar distortions, they're actually using the very same approach, the very same clipping, just like applied on purpose, which is quite interesting. So, let's continue with our project. So now imagine that we have created more or less a structure, and what we can also do with our input files, we can like cut them into small pieces, or for example try to extract something. We can fade them in and out whenever we need. We can pad them with a silence when we want to merge them like somehow explicitly interesting, and so on and so forth. And one thing that I found especially useful is splicing. The thing is that whenever you want to merge a couple of files, for example, like just you take two files and you want to merge them, it could happen that the transformation, like this transition from one file into another, will have this pretty much disruptive point in between where one file goes into another one, which is again pretty much, well, could be perceived as an audio distortion. It could just distracting you from listening. So how to make it smoother? Well, you can fortunately just splice those files together, which will produce some sort of like a nice smooth translation from one into another one. And the only thing you need to take care about is a size and amount of window, amount of access and leeway you want to use for your splicing. The only thing is that, yeah, essentially the bigger this window will be, the more resource computational heavy this operation is going to be, so you have to just take care of it. So, effects. After you have finished with the structure, you essentially can apply any effects you want to your files, to your input files. For example, you can create an echo effect, which sounds pretty interesting. Or you, for example, want to pitch some particular voices, which could be also pretty interesting. Essentially, you can be as creative as you want here to be, and Sound Exchange provides us some amount of predefined effects that we can apply. But here is a trick. Actually, almost all of those effects are actually under the hood, is just playing with different frequencies. So what does it mean? It means that whenever you have some effects you want to actually create, but there is no such effect, you can actually try to simulate this. For example, there is such an effect called a phone conversation. Like you can imagine when you're talking over the phone, your voice sounds a little bit different. There is no such effect in Sound Exchange, but you can simulate it using band pass filter. What does it mean? Here on this slide, you can see a command. A command called sing that will actually specify a range for your audio. In this particular case, we specify 500 and 3000. What does it mean? It means that we actually want to apply filter to our audio. We want to pass through only those frequencies. We want to even boost them in this case, and everything else we actually want to get rid of. We're not interested in any other frequencies. And even this filter will actually make our voice sounding a little bit more like muffy. As soon as you will, for example, add some generated noise, clicking noise on top of it, you will get pretty interesting phone-like phone conversation effect, which is just mind-blowing. Again, we can think about this visually. For example, here's a graph of this very command that we have just applied, and here we can clearly see the result of it. So on the x-axis, we see a frequency of our audio, and on the y-axis, we can see an amplitude, the response amplitude. And that's exactly what I have mentioned. The frequencies between 500 and 3000 are going to be significantly boosted, and everything else is just not interesting for us. After you've applied all the different effects and everything you wanted to, you may find that Sound Exchange could save your day, sometimes even more than that. Not only Sound Exchange allows you to process some audio, it allows you sometimes to generate some simple snippets of audio. It's of course not going to be that straightforward. You will probably not be able to create something absolutely fantastic, but sometimes it could be pretty useful. So, for example, that if you will execute the command presented on this slide, you will get a sound similar like this. Sound interesting, isn't it? So, And after all, after you have finished everything, applied everything, created your final result, and you're just like randomly skimming through the documentation, you will still find interesting things, interesting bits that you had no idea they even exist, but still Sound Exchange again saved your day. One of those examples is actually dithering. It's an approach that is being used like casually everywhere in sound, and like signal processing, image processing. And the common idea you may think about this approach is as like adding some random noise on top of some signal. The reason is, the point is that when you, for example, try to apply some transformation to your audio, sometimes you error or some other kinds of errors, and the thing is that they're actually annoyingly repeating. This annoying repetition means that they could be actually perceived as a distortion, as an audio distortion, which is again extremely not nice. And the simplest way actually to deal with it is just to generate some random noise, following some particular algorithms, there are many of those, and apply on top of your signals to kind of cover those quantization errors. And at the end, again, you will get much nicer even picture. So that, for example, on this particular slide, you can see actually a visual representation of dithering for an image processing. So there is an original picture that was taken just with a white and black, but to make it a little bit more pleasing to look at, some random noise was added so that the overall experience will be much better. So, and now we're more or less done, and just to summarize. The original goal was pretty much challenging, to create some audio project with no prior experience. It's like, I would say, it's extremely challenging, and it's even more pleasant to see that I actually managed to succeed with it using a tool that probably had to get more recognition and more attention to it actually. Not only I have managed to reach my goals, I was actually able to learn a lot of interesting stuff on the way. For example, I literally found, at the end, I found myself reading some Wikipedia articles about signal processing algorithms and all this mathematics. Like, how cool is that? So, anyway, we're done with this part of the presentation. Thanks, everyone, and bye.
And again, I'd like to thank Dimitri for his patience with the earlier technical problems. There won't be a Q&A for this session right now. Would like to throw out a thank you to our sponsor for track 2, AWS, and direct everybody here to the social events that are happening